Hello everyone. Today we will be continuing our conversation on Chapter 2, and we will be reviewing the second section of this chapter. And to begin with, when we look at descriptive statistics, where we left off last time, we were talking about graphic representations, and we looked at a couple during the last presentation. And so these are graphs of frequency distributions, and I have one right here presented that we looked at last time. So the data distributions can be described in terms of a central tendency and variability. And measures of central tendency include the mode, which is the value that's most often represented in the data. So the most people in our sample, just to give you an example from this graph, took about 45 minutes to run in a 5K race. And then the mean, the second measure of central tendency, is the average of the data set. So it's when all of the values in our data set are divided by how many people were actually involved in our study. And then the median is a value that is in the middle. So we order the values from least to greatest, and the middle value is the median. And so on this next slide, we actually have a great graphic representation that's presented in the chapter. And here we have all three measures of central tendency, and they provide a great example up here as well of what it actually looks like with the number of people and the test scores that they received. So the mode is 3 because that is where most people scored on the test, as we can see on here. And then the mean was 3.27. So they added all of the values and then divided by the number of people that participated in their study. So we have 1 plus 1 plus 2 plus 2 and so on and so forth, and then they divided by how many people were actually in the data set. And then we can see the median, where we lined up from least to greatest how many data points did we have. So we had 1, 1, 2, 2, 2, and we go from least to greatest, and we find that the middle number is 3. So continuing on with descriptive statistics, we talked about central tendency, and now we'll talk about variability. So measures of variability really looks at the spread of the data. And so we have range, which is the largest data point minus the smallest data point or score. And then we have standard deviation, which is the average difference of scores from the mean. In other words, how far are the measurements from the center of the distribution? So how far are the points away from the mean? And here we can see an example. So let's look at this example. This graph plots IQ scores of both men and women. And from this graph, we are able to tell that there is more variability in men's IQ scores compared to women's. So we see the men's is the purple line and the women's is the orange line. And so here we see more variability. So men's, the range is more varied, and what we can see on here is that men's IQ scores range from, or extend from about 130 to 70, whereas women's IQ scores extend from about 124 to 78, meaning that men may have larger numbers or a larger proportion of people that score a pretty low score on their IQ, but also have more individuals scoring in the higher range as compared to women. And so that leads us to talking about, so we've talked about descriptive statistics, and we have a general sense of how we collect and how we actually examine data, but how do we use statistics in psychology? And so in our studies, what we ultimately want to do is to know whether there's a causal relationship between A and B. And one example that we could talk about with just with causal relationships, so what does that even mean? One example would be, does the amount of sleep that students get the night before an exam impact their performance on their test? So A may be the hours of sleep that you get the night before, and then B is how well do you perform on the test. So that's a causal relationship that we want to look at. And in psychology experiments, when we talk about variables, researchers utilize variables to determine if making changes to one thing can result in changes in something else. And so in our example, the amount of sleep and performance on the test are two variables of interest. And we could change around the first variable, variable A, so the amount of sleep you get, we could put them into different groups. Maybe group 1 could get 8 hours of sleep versus group 2 that would only get 3 hours of sleep, and then we could see how well did they perform on a test. And so again, we're looking at causal relationships and the different variables that are included in each study. Further, when we talk about different variables, there are two types of variables, and these include independent and dependent variables. And an independent variable is something that we manipulate. And within that example of sleep and test performance, sleeping, whether we have the group sleep 8 hours versus 3 hours, is an independent variable. We also have a dependent variable, which is something that we measure. So within that example, we wanted to look at their performance on a test, and so that would be the dependent variable. Another example is if we had people come into the lab and we gave them 1, 2, or 4 drinks and then measured their level of anxiety in giving a speech in front of people that they don't know. Our independent variable is how much alcohol they drank, whether that was 1, 2, or 4 drinks. And because we varied that, or we manipulated the number of drinks they had. Our dependent variable would be the level of anxiety that the participants felt or experienced, because that is what we want to measure ultimately. So this leads us to talking about correlational studies. And with correlational studies, correlations are patterns of covariation, or just really the relationship or the link between two variables. And a positive correlation is where both variables increase or decrease together. For example, the more caramel macchiatos I drink, my productivity increases. So the more homework I'm able to do after drinking so many caramel macchiatos. That may be an example of a positive correlation. An example of a negative correlation where one variable increases as another decreases may be, I would take my allergy medication, so I increase my allergy medication to 1 pill a day. I will lower my chances of getting a cold or sinus infection. So as I increase my amount of allergy medication, my chances for getting a sinus infection or a cold decreases. And so this will make a lot more sense when we look at graphic representations of these, and we'll continue this discussion even on into the third section of this chapter. So here we have examples of correlations, and this is an example of a strong negative correlation. So as we can see, here are our variables, and we have 10 participants within this small study. So GPA is what we want to measure, and hours of TV per week would be our independent variable. And GPA again would be our dependent. And so when we look at this correlation right here, as the number of hours we watch TV increases, what we see here is that our GPA decreases. So again, this is an example of a strong negative correlation. And as we can see, we also have a R, which is our correlation coefficient, at a negative 0.63, and we will talk about this in this next slide. Correlation coefficients. This is just an additional piece of information that's provided to us about our sample. And the correlation coefficient is a measure of the direction and the strength of that correlation. And so this is just more information about that link or that relationship between the two variables that we're trying to measure. And so this ranges from -1 to +1, and the strength is indicated by the number. So the closer that little r is to 1, the stronger the link is between the two variables. And so in the previous example, if we look at this, the r is -0.63. And so because it is closer to 1, whether it's a positive or negative, it is still a strong correlation. And so again, the positive or negative sign does not matter when determining whether the correlation is strong or weak. Furthermore, when we look at whether the r is closer to 1 or is equal to 1, when it's equal to 1, that is a perfect correlation, and those are very rare. So the second measure that we want to look at is direction. And direction is indicated by the sign. So whether the correlation is positive or negative is indicated by, again, of course, the positive number or negative number. So negative numbers mean that as one variable increases, the other decreases. Otherwise, it is positive. And so that's a lot of jumbled words for you, but here we have some graphic representations of what it actually looks like. And so if I was to ask which correlation is actually strong, here I'll go back. So if I was to ask which correlation coefficient is stronger, -0.80 or +0.20, which one would it be? -0.80 is the correct answer. So remember, when asking about the strength of a correlation or the link between two variables, you ignore the sign and you look at which number is closest to 1. So here are 3 kinds of correlations. Here we have an example of a perfect positive correlation, because as one variable increases, the other increases as well. Here we have a perfect negative correlation. As one variable decreases, the other decreases as well. And then the last one, we don't have any type of link between these two variables and the data is just scattered. Another piece of information, so we didn't look at the R's yet, the correlation coefficients yet. So if we go back to this first graph and we see that R equals 1, well, we know that's going to be a perfect correlation, and so it's going to be a straight line. Again, here we see an R equaling -1. So automatically that negative sign is going to tell me that it's a negative correlation. So as one increases, the other decreases, or both decrease. And so R equals -1. That's again a perfect negative correlation. And then the third is R equals 0, where 0 means there's no correlation between the two variables and it's just scattered. So they're not related, they're not linked, they're not associated. Again, when we look at these first two graphs, they're not actually realistic due to measurement issues, which we'll discuss in the third section, because these perfect correlations, we really don't ever see those. So here's some more correlations and what they actually look like. So positive correlations of different strengths. So here we have different R's. And so again, R equaling 0, there's no pattern, there is no significant link between the two. And as we can see, as the R's are getting closer to 1, we're starting to see a perfect correlation or a straight line. And so here we see R equals 0.3 all the way to 0.9. And again, as you can see, as they progress towards R equaling 1, then we start to see a straight line. And so with this ends the second section of chapter 2 in talking about correlations. In the next section, we'll go more in depth into correlations and also talking about how do we actually choose the participants that we want, and also how do we assign them into specific groups of our different variables that we want to measure.